Hey everybody, welcome to Silent MFA with Generative AI. My name is Dr. Benjamin Manning. I am a research faculty member at Georgia Tech, and I'm really delighted to be here today to talk with everyone. Let's see if I can switch my camera on right quick. Say hey. Hey everybody. Again, my name is Ben Manning. My contact information before I dive in is right here on the screen. bm157@godtech.edu, or you can catch up with me on LinkedIn if you'd like. I'll turn my video off now, so my mother always said I had a face for radio. So welcome to my talk today. I'm going to dive in and cover something that I've been working on and all for quite a while now, actually. I've been in the industry for about 30 years, started my work in machine learning and AI way back in 1995. Spent about 25 years almost in industry before I went back to school, got my PhD in electrical and computer systems engineering. I've been fortunate enough to work as an AI engineer, as a data engineer, as a data scientist, security engineer, all these cool jobs now that weren't actually industry roles 20 years ago. We just did all the work anyway, right? So now I'm fortunate enough to work at Georgia Tech at the College of Computing in the online Master's of Computer Science program as a research faculty member. And my specialty area that I'm diving deep into is secure multi-agent systems. So I want to dive in today and talk to you about something that actually started years ago. I've never been a huge fan of MFA, but obviously it's something that has just sort of, the need has forced itself upon us, right? And years ago, I wrote a paper called Extreme Gradient Boosting and Behavioral Biometrics. I was really diving into sort of a new way to do MFA. Is there some sort of other way that we could prove who we are versus using Duo or using Microsoft Authenticator, all these different things that we just hate doing and hate interrupting our day with? Is there a more passive way that we could perform this sort of mandatory or beginning to be mandatory operation back then? And so I actually found there's a really interesting set of guidelines out there around keystroke dynamics. Turns out that we all have a specific way and a specific signature around the way that we type or the way that we actually input into a system. So I did some more research years ago, really became familiar with the study of behavioral biometrics, and found a great, actually 3 different data sets on keystroke dynamics. Did the work, did the experimentation, built multiple models around this data set. Back then, XGBoost, the good old ensemble XGBoost, was the best of the 3 that I tried. Came out with 93% accuracy, obviously with a pretty strong predictive power. That data set covered 51 different typists. Each typed the same word 400 times, gave me about 20,000 observations with 34 variables representing different features around timing. So basically what I was trying to do was build an MFA system that could recognize that you are you without having to bug you during the process. This solved 2 problems. Number 1, the user friction would go way down. And number 2, there was more than 1 point of entry, right? And we'll talk about what that means in just a minute. So again, XGBoost was the best. Dove into C5O and KNN as well to get some neighborly results out of that. And behavioral biometrics could be integrated into MFA or used for some other continuous verification. I didn't go into that process, into the integration process. This was an AI conference that I was writing this paper for, so that's the implementation stopped there. So moving forward a little bit, we still obviously even today have even more so interest and need for MFA, right? We've got passwords, we've got pins, we've got key phrases, we've got tokens, we've got devices. We're still diving into biometrics. We've got all these different things for MFA building this layered defense, right? And Obviously, it's a pain in the butt sometimes. We do have high user friction. We are continuously interrupted. How many times do you go to switch Microsoft 365 instances to a different mail service or a different organization, and it pushes you right back to Authenticator, right? Or it logs you out and then pushes you back to Authenticator. So there's just a lot of user friction there. And this one entry point concept that I talked about a few minutes ago, if you think about it, we do MFA right up front and we don't really do it again. It's kind of done at that point on most of our systems. Well, what if I change in the middle of that system, right? If I really want to protect something, that MFA checkpoint needs to be passive, and it needs to be really almost continuous, or at least at a higher frequency than just at the door. If someone came to your front door and came through the house, right? Came into the house, you're the person that's going to let them in. You're the person that is sort of the first line of defense. They knock on the door, you peek through the window, there's your first line, you let them in, you validate, yep, you're a known person, you're trusted. Well, what if they come in and they have something else nefarious? Maybe they got a backpack and somebody else is in there. Who knows? All these different funny things and analogies that I could make that beat this concept of one entry point. So we need something that's a little more continuous, right? Attack sophistication is increasing. This is nothing new. Deepfakes are upon us. SIM swaps. We've got all kind of phishing efforts. How many emails do you get a day, right, that you've got to dump? User frustration is really big. A lot of people, how many of you sign up on a new project? It's like, okay, do MFA or skip and do it later. Skip and do it later, depending on what it is, right? The passive approaches we have now are just way too limited, and there's no real robust framework for sort of an invisible AI-driven authentication, and that's what silent MFA is really about. So there it is, silent MFA. It's frictionless authentication through passive signals. And the instrument that I've used for this is generative AI, building on what I had done previously in the world of behavioral biometrics with XGBoost, KNN, and C50. I wanted to really refresh this work and see what aspects generative AI could actually bring to bearance. So what I use generative AI for, and on the expiration side of things, I need to synthesize user behavioral profiles, right? GenAI, as we all know, is fantastic for building synthetic data sets. A lot of this stuff I don't have, and a lot of this stuff I don't even have a way to capture, right? So building or synthesizing data sets around behavioral profiles, making up users, if you will, and features that go along with them, was essential, for proving this type of work. Then evaluating the robustness of the framework with synthetic adversaries, intruders, and then overall reducing the friction while also maintaining the trust. If someone can come to a system, they're automatically logged in based on some of these behavioral profiles, and that is continuous and seamless and passive through their entire user instance. And it's trustworthy. So those are big things. So challenges, right? Interpreting and integrating the passive signals. What can we do with the data? Distinguishing a real user from an adversary. That's a big one. We talked about deepfakes becoming a big deal now. I do a lot of work in adversarial AI already. This is a little bit different than the core work in adversarial AI. That's really on the system side and the pipeline side. This is an external, red team sort of attack. And then obviously, like I just said, ensuring trust without friction. So research questions that I was trying to solve. These are a little bit duplicates here. Can generative AI infer user identity from passive signals? How does silent MFA compare with traditional MFA? And what are the risks under adversarial attempts? And that's the hard one. It turns out. All right, one more. So here's the proposed approach. So going to use generative AI to generate a lot of synthetic data around keystrokes, device metadata, context, writing style, and where I was able to, actually fold in existing behavioral biometrics that can go along with these things. The deeper the dimensional space gets, right, on the feature side of things, the more rich the generative AI methods seem to be, and that goes hand in hand with just the way obviously LLMs are built. So here's the good stuff. How did I do this? Step one was data prep. Like I said, I used an LLM to build synthetic data, combined it with real behavioral biometrics, did typical pre-process that data into embeddings, just use foundational models here. We popped the top off, and and used traditional LoRa type methods to build a new set of adapters. So we froze the original weights and then built in our own fine-tuning methods above that. Step 3, there's your LoRa fine-tuning. Step 4, inference and authentication. This is the very last step, and how we really start to kind of get into the weeds and put this into practice. So we've done gone all the way through that process with synthetic data now. You want to dive into the model architecture? Here it is. We experimented with a handful of foundational models for this. There's nothing like super cool that I built as far as LLMs are concerned or anything like that. I took the traditional method of a foundational model, froze the weights, did fine tuning on it, and then built a decision layer sort of at the end of that. Nothing super out of the ordinary that you wouldn't have done for pretty much anything you're going to fine tune with a foundational model, right? There was nothing. The discovery was not here. The discovery was in the application and the synthetic nature of the training data. So how did I test this? Very similar to what I did in the very first paper. Accuracy, false acceptance rates, false rejection rates, user friction index. There's about 4 different items there. Quantifiable measures in the user friction index, you can look that up. And then adversarial robustness based on some of the other work that I've been doing in adversarial AI and some of the frameworks I've built there. So just a quick dive on the synthetic piece of this. The results were actually really good. Your traditional MFA generally sits around 95%. The ML classifier that I built previously with XGBoost was at 93%. What I'm at so far on the silent MFA with foundational models and signals is 97%. And I'm working on this piece now, sort of the adversarial side is around 90%. And that's where the hard part of all this is, whether it's traditional MFA or not, right? Adversarial is quickly becoming a thorn. And but the focus on this particular chart, the silent MFA piece of it, accuracy was really high at 97%. Your FAR and FRR were really low, and the folks that have used this so far, the 4 quantifiable pieces of the user friction index came out to be low, which was one of the research questions we actually posed when we started this, was can I build something that is easier and passive and doesn't bug you to death as far as MFA is concerned. And so far, so good. So continuing the discussion, this method does reduce friction while maintaining accuracy. GenAI does enhance inference from context, albeit synthetic. The weakness piece of this is the adversarial piece of it. When I pushed this method a lot with some adversarial frameworks, the accuracy does go down, and there were instances where even the synthetic data was able to be sort of picked apart on some of the adversarial side of things, which was really interesting. Interestingly enough, that was generally right out the door, right out the front gate. So it was like, okay, you could get in, but the continual nature of the framework that I've put together would stop it down the road. But I don't consider success until all of those instances are the same, right? So a lot of damage can be done just getting in the front gate, if you will. So I'm going to expand this to some multimodal signals. I'd love to add voice and maybe a few other things. Vision is really high on my list. A lot of work in that area too, but again, I want to be very careful of the intrusive nature of that. That's very hardware intensive and extremely intensive on the inference side too. So I have to be careful there. Obviously, improve the adversarial defense side of it. Do want to put this in a real world deployment. So if we have any guinea pigs out there listening to this, bm157@gatech.edu. You can email me if you want to be the guinea pig. And as it rolls out, the other policy-based things, governance, privacy, compliance, we still have to. I still have to tack some stuff on there too. So, but got to get it done first. So, wrapping this up, silent MFA with GenAI is a promising path to secure frictionless security. The early results are pretty encouraging. Does bridge usability and security, but and everybody's hit this wall. Adversarial robustness is critical. Still something I'm working through, and I'm calling this silent MFA. Again, this is something that happens in the background, stays in the background, makes your user experience much better, is passive for the user, and continual. Those are three big areas that we don't address right now in most common systems. And I think the need is going to be even further necessary down the road to not only validate at the front door, but continue that process in a passive way down the road. So this was a great time. I had a great time doing this. Like I said, it's based off the paper that I originally wrote almost, goodness gracious, almost 8 years ago now. So I had to dust it off, get it out of the basket, and redo a few things. So I really had a great time doing this. I'm excited to see where it goes next, and happy to answer any questions. Y'all want to email me directly or connect with me on LinkedIn. Thank y'all so much for the opportunity to present today, and enjoy the virtual conference, everyone. Have a good one, everybody.